So some time has passed since the last video, so if you're watching these in sequential order, I do apologize. We've upgraded our racks to a 5-slot rack. Essentially, it has one more spot up on top, and as a result, it's changed our plan for how to explain and wire these things. That being said, today we're going to show you how to wire these up and get everything ready to go. So to wire these up, the first thing we need to figure out is what size wire we need. So in today's example, we're using a Solarc 5K. The maximum this can take in and put out to the battery is 5,000 watts. So if we take 5,000 watts and divide it by 51.2 volts, which is the nominal voltage of these batteries, we get just shy of 100 amps. So if we then take that number and look at our chart, that's going to give us a 2-gauge wire. Now, while we did get a 2-gauge wire as our minimum, it is also okay to go over that. So today I already have some 2/0 jumpers ready to go. These are 9 inches from center to center, which is the perfect length. We have these pre-made here at Current Connected. I'll put a link down in the description. So like I said, I'm using 2/0 for my battery-to-battery connections, only because I'm going to be doing multiple demos. 2-gauge would be perfectly fine, and in fact, I'm using 2-gauge wire to go from the rack to the inverter. So just to give you an idea, it's based on the inverter you hook up, not necessarily the batteries. Now, one thing that may not make sense yet, but is worth noting, the feed-through current from one terminal to the other is 350 amps. That means if we had 350 amps coming through our cable, going through the battery and back out, we would be fine, but if we had more than that, it would be a problem. This is an important consideration if you're doing racks with large amounts of batteries. Let's say it's not the 5-slot SOK rack, let's say it was a EIA server rack. That's when it would be important to take note of that feed-through current. But in today's example, we're not going over 100 amps, so feeding through the terminals of the battery is no problem. Now, these batteries do come with terminal protectors. However, these max out at 2-gauge wire. So for the 2/0 wire I'm using today, they wouldn't be big enough. Essentially, this hole here on the side is not big enough to stick the wire through. So I'm going to be omitting them today, but if you were using 2-gauge wire, these are included with the battery. You can feed your wire through, bend it back, and then put your screw in. Before getting started, we want to make absolute certain that the circuit breaker disconnects are turned off, and then out of precaution, I also have the BMS turned off. If your BMS is on, click on the card in the top corner. That's our video showing how to turn them on and off. You could follow that to get it deactivated. I like starting from the bottom up, so here we are at the bottom of the rack. First thing I'm going to put in is my red wire here. So I'm going to get the screws all started hand tight, and then in the end I'll come back and torque them. Now, something that's really nice about this 9-inch length is it gives us a little bit of extra wiggle room. So if we bend them in the middle a little bit, they fit perfect. But the reason I wouldn't want this to be the exact length from center to center is because if we have any deviation or tolerance here, it's just not going to fit. So that's why 9 inches is the perfect length. So I've got positive on here, and then I'll just stick negative on here like such. The next step is to torque these to the appropriate torque. Now, at the time of recording right now, I don't have that exact torque spec, but I'll make sure to get that from SOK and put it in the description below. So for now, I'm just using a 13mm ratchet wrench here, 6 points so that it doesn't spin and strip anything out. And I'm just going to tighten these nice and tight. But again, highly recommend using a torque wrench and checking that value in the description below. We need to connect our battery cables to the Solarc. So here in the Solarc, this is where those connect on. We also have a DC disconnect here. You'll note that that is currently off. So our cable feeds in through the bottom, and then our bolts just thread into this terminal block here. And Solarc conveniently provides us with the application note to tighten these connections to 90 inch-pounds or 10 Newton meters. On the wires going to the Solarc, I'm using a 2-gauge wire, so I can actually take advantage of the little rubber boot. So here I have the screw already in there, the boot folded back, and where these cables go is also very important. I'll explain why in just a moment. I'm going to connect my positive to my bottom battery as such, and my negative is going to go at the opposite corner to the top battery. Now, why would you put them on opposite corners instead of just the top battery? Well, it's pretty simple. If we connected both cables here on the top battery, then the top battery would be the battery with the least amount of resistance, so more current would come from that battery than the rest of the stack. By going in opposite corners, we're split evenly across all of the batteries, and they'll draw consistently. Additionally, if we hit these batteries with a heavy load, the top battery may be drawn from with too much current, and that can cause it to shut down, leading to a cascade shutdown as you go down the rack. So always connect to opposite corners of the rack like we did here. Now we're all hooked up for basic voltage controlled function. You can click the video on the left for the startup procedure for how to turn these on, or you can click the video on the right for our next topic, where we show you how to hook up communications for this type of application. See you there.